All right, guys, this is our lesson on dangerous waves. So we are going to be talking about the electromagnetic spectrum today. We're going to talk about the whole thing. We're going to start with the lowest energy. So we're talking about the least dangerous wave and work our way up to the most energy, which means we're going to talk about the most dangerous kind of waves today. All right? So the way we're going to talk about the energy measured is in electron volts. So that EV that you see on each slide, that is the electron volt measurement that we would consider in that range for that kind of wave. So it's not just a single measurement that counts as that type of wave. It would be a range. So not all the waves, not all radio waves have the same EV. There is a range of different kinds of radio waves. All right. So again, we are starting with the lowest energy and working our way up to the most energy. So the first kind of wave we're going to talk about is radio waves, and they have less than 1/1000th of an electron volt. So that's really low energy, so they don't really affect us too much. Now, we'll talk about where they're used in everyday life too. These are used in radio waves. So they're transmitting messages to radios and other short-range devices like a walkie-talkie or your Bluetooth headphones. Anything that connects with Bluetooth is using a type of radio wave. All right, the next kind of wave is a microwave. So it's what's used in your microwave in your house to heat your food. Okay, so they cause internal heating, and so each little atom heats from the inside out. Now, when you're heating your plate of food in the microwave, it feels like the middle is really, really cold and the outside gets hot. So each atom is heating from the inside out, but those waves have to penetrate the whole plate of food for them to heat each piece of food. So in a way, it does heat from the inside out, but also from the outside in. So as a whole, that whole plate of food is going to heat from the outside in because those waves start at the outside and work their way into the middle of the plate of food, but each atom within that food is heating from the inside of the atom to the outside of the atom. Now that's a little bit confusing, but just kind of to give you an idea of how those work, okay? Right, the microwaves you have at home, they do not create enough to seriously hurt you. Now, it's not smart to put your hand inside of a microwave and try and turn it on. That's why there are safeguards on your microwave, so your microwave won't turn on unless you've got it closed. And that mesh that's on the front side of the microwave, that's actually metal, so it slows down those waves. It doesn't allow them to leave the microwave itself. Okay, so if you are hit with a ton of microwaves all at once, it could kill you, but the microwaves at home don't create enough, and there are plenty of safeguards to keep those microwaves inside of the box of the microwave itself. The next kind of wave we're going to talk about is infrared. All right, now infrared waves, they have 1/100th of an EV up all the way up to 2 whole EVs. Okay, so these are what we call heat waves. So if you've ever used heat-seeking goggles or infrared goggles, it would probably look something like this picture over here on this side. So it kind of gives you a gradient effect. So it gives you a rainbow effect of all the different colors that match up with a specific temperature. Okay, so if you look at the little range over here, it's telling you what temperature each color matches with. So it goes from cool down here at black and works all the way up to red up here, and that represents the warmest areas. Now, there are some areas that are pink right here. Some of the goggles and some of the infrared rays that you see, they actually will turn white instead of having that pink in that section. It'll just be completely white, and that would represent the warmest temperature. Now, some of them are completely different, so you have to look at the temperature range for each one to see what that means. Okay. Now, heat can hurt humans if there's a whole lot of it. We can get what's called heat exhaustion or heat stroke, but for the most part, heat doesn't really hurt us that much. All right, the next type of wave we're going to talk about is visible light. So this ranges from 2 eV all the way up to 3 eV. So it's a small piece of the electromagnetic spectrum, but that wavelength, that energy, tells us what color we're looking at, okay? So if we start with red, that's our lowest energy, and it goes all the way around up to blue. Remember we talked about, well, it turns into that kind of reddish violet color right here. That is the highest energy wave as far as light. So we talked about this already in our last unit. We talked about how blue light has a whole lot of energy, and that's why it makes your eyes tired, and that's why they make those nighttime filters that are kind of orange or yellowish on your phone. That's to kind of help cut down on the blue light so it doesn't tire your eyes out as bad. And it also makes it easier for us to sleep at night. All right, the next type of way we're going to talk about is ultraviolet rays. Okay, so this is what make people tan. They come out of UV lamps. That's what's in a tanning bed is a UV light. This is also what can cause skin cancer if you're exposed to too much of it, or if you just have really sensitive skin, it can cause those kinds of issues for you as well. So there is a huge range. If we look up here, there's a huge range of ultraviolet lights. It goes from 3 EV all the way up to 1,000 EV. Okay, so when we talk about sunscreen, a lot of times you'll see that they block UVA and UVB rays. That just means that they're blocking that whole spectrum of UV light. All right, the next type of wave we're going to talk about is an X-ray. Okay, these are given off by machines to take pictures of the bones in your body. Now, any of you, well, obviously can't answer my question, but if you've ever had an x-ray, you'll notice that the nurse or the x-ray tech or whoever's taking your x-ray will walk out of the room to go press the button to take the x-ray. That is because they do that all day long, and if they're exposed to it constantly all day long for a long period of time, it can cause issues for them. It could cause cancer. It could, if it's a whole lot all at once, so like a really high-powered x-ray, it could kill you. But again, we don't use those really high energy x-rays. We don't use the ones that are all the way up here at 100,000 EV. We use the lower level ones to create those x-rays because it works and it serves our purpose and it's less dangerous for us. Now, most people are not going to have anywhere near enough x-rays to make them sick or maybe possibly cause cancer, but those people that work day in and day out taking x-rays walk out of the room so that that's not an issue for them. So that's why they deliberately put that button to take the x-ray outside of that room. And that's also why, if you've ever been to the dentist, they put that metal, almost like a bib over you, is to keep the rest of your body safe from the x-rays. Okay? Now, that's not saying that getting an x-ray at the dentist is bad. They're just trying to protect you as much as they can. Okay? All right. And the last kind of ray or waves we're going to talk about is gamma rays. And this little symbol right here is the Greek letter gamma. But I spelled it out so that it was easier for us to talk about it. But that funny little symbol right there is the Greek letter gamma. Now, gamma rays have an energy greater than 100,000 EV, and that's a really, really high level. Now, gamma rays, well, radiation itself, we can use the lower levels of it to treat cancer. So we can direct that low level radiation at the cancer cells and it kills those cancer cells. Now, there's a double-edged sword there. If you expose your entire body to radiation, even those healthy cells to radiation, then those healthy cells can become cancerous. So when they do radiation treatment, they deliberately target it directly at the tumor itself just to kill those cancerous cells. All right. So those doctors are using all kinds of safeguards and all kinds of precautions to make sure they're not hurting you. They're just trying to get rid of that cancer cell. Okay. Now, low level radiation over time can cause radiation poisoning or even cause cancer. If you get exposed to too much radiation all at once, then that can cause radiation poisoning. And radiation poisoning is really, really bad for us. It's really nasty. And that kind of takes us to our last slide. Okay. We do try and harness radiation. We try and use it for energy. We've tried to create things with it. And for the most part, we've been fairly successful with it. Now, Chernobyl is a nuclear power plant in Russia, or it was. It's still there, but it's not used today. And this video will kind of explain why it's not used anymore. We didn't really know a whole lot about radiation. We didn't know a whole lot about nuclear power when we first started using it. We knew that it was a really clean way, clean for the environment at least, a clean way for us to create energy. But that doesn't necessarily carry over to it being perfectly safe. So when we talk about using nuclear power, it's not always the safest thing for us to use, but we are really careful with it when we do use it. And Chernobyl did teach us a lot about how to be safe with it. But again, it's still not perfect. It's not the greatest way that we can create energy because it's not super safe for us. But that first video is telling you what happened at Chernobyl. It was a nuclear power plant. It melted down, which means that it malfunctioned. And that video explains better what happened there than me trying to explain it without showing you. So that first video is telling you about Chernobyl and what happened at Chernobyl, and then the second video explains what radiation does to our body. Now, again, when we're talking about radiation to treat cancer, it is very different than what would happen if you were exposed to radiation, say at a nuclear power plant where it wasn't being used safely. This video is just talking about what happens if you're just generally exposed to a whole bunch of radiation at once. All right. That second video explains why radiation is dangerous to us and what it does to the human body. All right, and that's all I've got for the electromagnetic spectrum. This is how it can be dangerous, but also how it can be helpful for us.